based on my personal journey and experiences with reproducible research. Basically, I'll be singing an ode to R. R is a statistical software which paved my way to reproducible research. So having said that, even if you are not an R user, please don't fret. I will not teach you R here, not now. I'll simply give you a buffet of items related to reproducible research practices. Some of these ideas might be already familiar to you. Some of these ideas may overwhelm you. Some of these ideas may be totally new to you. I would suggest you to pick anything you want because this is a buffet. So I would start with this news which came up very recently in Nature, which said different researchers could not produce same results from datasets. This surprised me because when I started with research in the beginning, I always thought if there is one dataset and there are 10 researchers, all the 10 researchers would arrive at similar results because it's the same dataset. That's what I thought. But this news startled me because 246 people did find different results from the same datasets. So I will let this simmer onto your brain and I'll move to the next slide. So this is where I started. It's not moving. So it's nothing to do with my system. Skip. Slides open. Okay. Sorry for the glitch again. So this was my PhD life, and I believe even you can relate to this story, what I'm going to narrate. So I collected data from human participants and I analyzed my data and I wrote reports, I wrote manuscripts, I wrote my thesis, and then made presentations. This looks more like a linear journey, but the problem with this is not a linear journey. So I had to go into different bits of data sets as I went on to collect, and I had to analyze at several levels. I had to go back to the old analysis and the old data files, and just imagine how many times I had to update my manuscript and also my presentations. So it is basically rerun, copy, paste multiple n number of times. So this alarmed me because that time Excel-based errors started coming up in news articles. So this was one another article which was published in Nature. Please, I would invite you to enter a parallel world where people just push a button to produce all what I said now, including presentations, including a paper, including an updated analysis. So this is a parallel world, but this exists. But this is no magic button. You are there behind this button who write all the scripts, who make the presentations, who write the initial scripts for making the manuscripts. But then the best thing is you don't have to rerun the analysis several times, but you can just render the project and everything, including a manuscript, including the numbers in the manuscript, tables and everything, including figures, gets updated. So the outline of my talk would be what is reproducibility to introduce the concept, and then I'll move on to 3 best practices for reproducible research. And I also will present some advanced moves of reproducible research. Can I kindly request the participants to mention in chat if any of you have used R, because that will help me to tailor the talk. And the final thing we will touch upon is useful resources and directions if you want to embark this reproducible research journey. And I will close the loop by bringing down to how this empowered research. So is there any one who's using R or who are already familiar with the R environment? I believe no one. Okay, thank you. So let's begin with what reproducibility simply means. I present you a concept of reproducibility spectrum. I want you to imagine reproducibility as a spectrum. I would want you to concentrate on the right end where an yellow colored gold standard full replication is presented. So this is the cornerstone in research wherein I believe many scientists will agree with me when I say this, that no single study, no single result from a single study will be considered as a scientific evidence, whereas it requires one or several rounds of replication to become a standard scientific evidence. Towards the left, you see, or in the middle part, you see what is a group of publication with code presented, code and data presented, moving towards full replication. And on the left, you see what is called as a publication only. I believe most of us will be there, which is not reproducible. That is, if you present your paper as a PDF, no one can check your authenticity of the results. No one can rerun the results because it is just a PDF. Having mentioned replicability and to and I have seen this both replicability and reproducibility being used interchangeably. So I would want to have a very brief difference between reproducibility and replicability. That is, both analyze same research question and same results. Whereas if you do the reanalysis in the same data, that is reproducibility, and if you gather new data to test the research question, that is replicability. This is a simple way I understand this. And there are several types of reproducibility. Seeing the general audience, I do not want to delve into each and every type, but let's pick a very reductionist view, at least for this session. What I mean reproducibility is, let me say I just completed a project and I finished my analysis and I wrote a paper and I wrote a report. So I want my friend or my colleague to rerun this analysis to arrive at the same results. This is a reductionist view. A still more reductionist view would be, can I reproduce my own work? Whatever I wrote it. So can I push the button again and arrive at the same results, or will it change? Arrive at the same results to the decimal point, I mean. So having dedicating a talk to reproducibility, so I ask myself, so is this an ideal aim to achieve in research? Like, should we all go there? I would say it is a minimal standard at least. And having said that, it is also important to stress that it is a skill. Reproducibility is a skill you build deliberately and walk towards it. So I loved this representation, which was recently presented in one of the conferences. Again, it is same as what we spoke, but on the left end, nobody, not even yourself, can recreate any part of your analysis. And you see on the right end, which is the ideal end, is the push button workflow. So I would want you to pause here and think where you are in the recent analysis you did. Can you actually push a button and reproduce your work, or you are somewhere in between? Or if not, I would invite you to walk towards it. Let's say you are an old school and you do not want to upgrade and you are still with the old feature phone. What happens now? So you do not even want to do reproducible research. I'll tell you what happens. So this is a publication which appeared in Nature in 2021, where a research was done to test reproducibility of the findings, where 70% of the researchers were not able to reproduce findings from other scientists, and 60%, a whooping 60%, could not reproduce their own findings. And do you think it is easy? It comes with a price. It costs $28 billion every year in irreproducible findings. So I'm sure you'd be convinced now we need to do something to tackle this. So what can we do? So that's where I placed the second feature of this talk, that is best practices and advanced moves. So moving to best practices. So this is me trying to cross the hurdles when I learned R, walking towards reproducibility. Believe me, I stumbled at many places, but everything came as a learning. So I have distilled down my own mistakes and arrived at these best principles. I would say these are not the only best principles in reproducible research. There are several best principles, but I've made it three so that it is easier to remember. So the three best practices for beginners who are beginning in reproducible research is to remember organization, documentation, and to separate raw versus analytical data sets. Let's delve into each one to know why this is important, where I went wrong, and how I am doing now. What do I mean by organization? So, by organization, I mean a consistent structure. Why structure? Because a structure helps you to spot the mistake early and it is easy to reproduce and retrace. So, enter what is called as projects in R. I would want you to think project as organized set of books, which is depicted here. Only that each book holds your data and analysis separately for every project you do. So I have several instances when I am conducting a particular analysis, and then someone else, a collaborator who comes to me and wants an update in the analysis, I just shift projects in a jiffy and I go into another project and I can start the analysis from where I left and I can come back. So this is the beauty of projects, and it is very easy to start a project in R. That is depicted in the left. So this is how I have arranged all my R projects. So every folder you see has a separate data folder and all the analysis are held inside. So these are several of my projects. So if you're working on more than one project, I definitely want you to try what is called as R project. So if you think I have arrived at the golden end, I slipped. You know, the chaos you see on the left side is how I made inside a project. Even though I was able to separate out projects, inside projects, I slipped like this and I was not organized. And the problem with this is I was not able to go back to the file. I was not able to retrace my codes. I was not able to retrace my files. A reviewer asked me to update the figure. I was not able to do that. So that's why I put the quote here, which came as a revelation. So when you are not organized at the bottom level, the whole system collapses when you grow up, and it did, believe me. So I came up with a very minimal organization within the project. So inside a project, as I said, there is a data and there is, I write scripts, I write manuscripts. So this is the minimal a structure I came up with. So this gave me consistency and I moved from here on. But in R, I figured out there is a easy way, much easier way to do this. There are two libraries to do this, a project template, which by a single line of code gives you all these organization by itself. You see, it is much more detailed. You can delete whichever you do not want. You can keep adding whatever you want. But this is pretty easy to do within R. R helps you to be organized in certain ways. Let's say you are not an R practitioner. Can you still be organized? Yes. So what I am depicting here in this slide is a minimum viable organization which you can adapt, which is inside a data folder. You have a raw data folder, you have a code book, you have a metadata, and you can adopt this for your practice. And if you are interested to know more about organization principles, I invite you to read our recent publication in which we have elaborately mentioned each and everything in detail. So the summary of this area is, whatever you do to stay organized, think one question for yourself. Can I find it again? That should lead you to organize by yourself. So there is no right or wrong. You can do it anyway, but ask yourself, when you name something, when you organize something, can you find it again? You have to find it again. Let's move into what is called as documentation. And I overlooked this step when I started my R journey, when I did my reproducible research. I was not very aware of this concept. And then what happened is I relied mostly on my memory to reproduce or to retrace things. So you will understand down the line after 3 months or 6 months of my analysis, I was not able to retrace the files. Even if I could retrace the files, I could not remember why I made certain decisions during my analytic stages. For example, if I decided to remove the outliers or I decided to retain the outliers, why? I did consult this with a statistician, but I did not document it. So it was very difficult for me to practice reproducible research without documentation. So I would suggest not to do that mistake. So by documentation, I mean meticulous record keeping. So thinking of which, if you are beginning in research, you would think what to document. So I would ask you to document whatever you do, whatever you intend to do, whatever you did not do. For example, I had a log of my mistakes because I was learning R. I did several mistakes and I had a record of all my mistakes and how I corrected. So that helped me to uh, redo it again in a better way. And where to document? So one simple way to document is to have a simple markdown text or simple text file which is available across platforms and name it readme. So when you have a folder and you have a file readme, so anyone who opens the file will read that. Who opens the folder will read that. So where should you start? According to me, a beginner can start with code books. That's the best place to start. See, this is one of the summaries which I prepared for my data sets. So why don't you start with code book? So isn't it beautiful to see such a summary output for all your variables? What you see here is all the variable names and whether they are categorical, whether they are continuous variables, and if they are continuous, you see a histogram. Otherwise, you see missing values. So this was produced with single line of code again. So if you think of code books, even if you're not doing it via R, code books are a minimum requirement because when you arrange your data and when you label something as 0 and 1, believe me, down the line, even you will not remember what is 0 and what is 1. So it is important. It is a minimum requirement for a code book to accompany a data set. Then I also mentioned something about metadata. So what is metadata? So what you see on the left, let us consider that as a data where it can be continuous, discrete, and other things. Here the data is a figure. Let's imagine this is an image and this is data. And what you see on the right, you could have seen this in your own mobile where you find information about photographs. And there are lots of information about when it was captured on the date and name and other things. So this is metadata. Metadata is nothing but information about data. So if you're going into this is one of the sample metadata which we wrote recently, which describes information about the data. So if you're planning to write a metadata, make sure you add a title, description, the date, format, variables, and also the license. Because this will help anyone whom you share the data with to understand what this data is about without having to make a call to speak with you to understand what is 0 and what is 1. In R, we also we also comment our codes. And even if you read this, even without knowing what is R or R environment, you will be able to understand what my code is doing. For example, the top one says load the Palmer Penguins package. So I'm doing something to load a package. And the next one says view the first few rows of the Penguin data set. So it is straightforward and clear what I'm doing with the code. Even if you do not understand the code, you will understand my comment. And I also write, I also record, document my decisions, even as simple as why I want this figure to be retained. And I also have a session info document, which is very essential for computational reproducibility because there might be someone who is working with the Windows data set, Windows background, there might be someone who is working on the Mac. The platforms may vary and the results can still be the same. And there is something called as logger package, which helps you log on the go. What I have shown you is uh, this can be adopted even without R, I would say. For example, you open a text file and you write what you want to do. Here I have written, I want to count the species of penguins. And then I did that. Then I logged, I have finished my visualization. I want to try a color palette and I added my favorite colors. So you see on the right that whatever I have logged on the left is printed with date and timestamp. You might not have this date and timestamp when you do your own analysis and you write it by yourself, but it's a good way to start. And the important thing I would suggest as a best practice for a beginner is don't touch the raw data. So what do we do then? So often when we have the raw data, we have to clean the data and make it analyzable. So we have to learn to separate raw and analytical data sets, because for reproducibility pipelines, it is important to have the codes which make analytical data sets from the raw data sets, because without that, we will not be able to test what you analyzed, because there is raw and there is a gap between raw and analytical data sets. So we use what is called a script language, or what is called a scripts inside R. I'll tell you what is the main feature about this in respect to point and click softwares which are commonly being used for data analysis. So let's say in a spreadsheet, you just click something, you add a couple of variables, and then you multiply a couple of variables, and then you will never be able to retrace it again. Can you redo the same thing at the same stage of what you did? It's very difficult. Whereas in R, we write scripts for each and every step, and you run the script again, so it is doable again by yourself as well as by others. So this is, imagine scripts as a notebook. So whatever step you undertook from converting raw data to analyzable data, you are having a record of it. This is script. So this is my own workflow where I have scripts separately for importing, for dropping not available variables, and also making the data tidy. So what you see on the top is, I don't touch the input data first. I write scripts. And with every level of script, I convert to output, and each output is taken as input at the second level. If you move down, you will understand this better. When I write import.r, I simply import my raw data inside R, and I convert a data set which is imported CSV. Then I write a drop NIAAA script which will drop the next step, and it goes on. So if you are looking for one takeaway from this documentation, it would be my suggestion to document heavily. Nothing is more here. So seeing the generalizable audience, I'm tempted to skip this best practices for advanced uses, but I'll anyways just give a glimpse very quickly to show you the power of what we are doing in R for reproducible research. One is something called as version control, next is literate programming, and next is automation. Don't be carried away by these technical terms. I'll break this down for you. I am sure we all have been here. That is, we write several versions of the same paper and we name it final documents 2, 3, 4, 22. I'm sure everyone, even who are not in research, can relate to this kind of thing. So this is what happens when there is no version control. Imagine this for analysis, which is much more complicated because there are several stages of analysis you do. And there are going to be several versions of scripts, there are several versions of decisions and several steps. And it is much more complicated. That's where version control helps. Version control lets you time travel. Simply, what you see on the right is several versions of codes, whereas with Git and GitHub, you will be able to retrace any of those old scripts, and you can retrace your mistakes if you have done, or if you want to go back to your old script, you will be able to do that. So that's why I have put that it lets you time travel back in time. So what is literate programming? So literate programming is nothing but a document that is both machine as well as human readable. Can you imagine such a thing? It exists. So what you see here on the left is a script which is read by the machine. Here, what I mean machine is R, my system in R, which reads the code and produces the plot which you see underneath. Whereas what is human readable is the same piece of code. I have added a couple of lines above, which is readable by you and me. So this is a feature of R Markdown or Quarto. And as we speak, there is a new feature in Quarto, which is an open source scientific and technical publishing system, which is very upcoming for reproducibility and collaboration, and uh, which is very good for multi-format publishing. So we recently pushed this button and we produced this preprint. And what you see on the right is different formats on which I click, I produce the PDF. I click on a Word, I can create a Word document of this file. So this is multi-format publishing. Believe me, this was done in one click. So there is also something called as automation. When I said push button workflows, this script combines all my scripts, and with one click, I'll be able to run all my scripts. So that is the automation which I'm speaking about. So let's quickly move into the useful resources and directions. So if you're planning to conduct reproducible research, it also has some thorns on the way. Let's assume you are working with the human data. There are several limitations and there are several issues that might crop up, that might come up when you want to put the data on a public database. So I would invite you to read ICMR ethical guidelines for this. And I would want you to make your data fair. What is fair? Findable, accessible, interoperable, and reproducible data. Once I remember I had a discussion with one of my colleagues and I was speaking about reproducibility, and he mentioned, aren't we aiming too high? So, like, can we even do this? So that's the mindset which I want to change, which I want to see a change in this community, research community, because even ICMR ethical guidelines back in 2017 clearly has mentioned that we all have to make our data freely available for other researchers to check and use, quote unquote. So where can you start? Can you at least start with you? So I have these book suggestions. The disclaimer here is I do not receive any compensation for mentioning these books. These are just the reflection of my own journey. What you see on the left is the eye opener book, which upon reading, I learned about so much about reproducibility and started thinking about building a reproducible pipeline for myself. And the second book helped me do it. And the third book is much more advanced, which is Building Reproducible Analytical Pipelines, which is RAP in acronym. So if you're already familiar with the R environment, you can try reading this book as well. So there is also a community called R Ladies Community. I thought it is worth a mention, having this being a Women's Day celebration. So this is a group of people coming together who all are passionate about art. And you will also see that this is not just ladies group. There are also men. Men are welcome. And R Studio is now POSIT. So when you start downloading R Studio, you might see that as POSIT and don't be surprised. But still the software is still called R Studio. So you might have to install R and you might have to install R Studio. So having mentioned this, you might have a doubt, what is R and what is R Studio now? So I thought it's my responsibility to clarify that. So I love this analogy. When I came, I'm new to Gujarat. I'm not from Gujarat. When I moved into Gujarat, I was presented this plate. So this, I believe, what is called as dal bati. Am I right? Dal bati. Okay. So I did not know it has to be eaten with this dal. I gulped down this round things, which is bati, and it was very hard for me. That's what happens when you start working with R as a beginner. It will be very difficult. Whereas when you eat the same bati with dal, it was very tasty and it was very easy for me to eat it. That's how it feels when you start working with R Studio, because R Studio has inbuilt code prompts. So what you see on the top is my phone suggesting what I should type next. This even you would have experienced. When I say, why should I talk about, it suggests this, that, it. So what you see down is when I start typing LIBR, it is asking me, do you want library to be written? So this is how intuitive I would say R Studio is. You can pick to choose to work in R Studio because of this. And I would suggest you to start very small. So this was my attempt last year to just reproduce my own results, not the entire paper. Then you can, when you are confident with making reproducible documents, both Quarto and R Markdown, you can shift and you can transition to making reproducible full documents and full paper. And you know what? It is okay. No one expects perfection. When you start with a coding language, it is very difficult. And I love this on the what I have depicted on the left, that it is it is shown in our studio website that no one is born as a data scientist, and we are all complete beginners at some point. And what you see on the right is a pioneer in R who says even she makes errors in R. Sometimes it's a solace for me to see these giants making errors, having errors in their workflow, and it is okay. So these are the women I admire in our field. So what you see on the left is Kara Thompson, who has excellent social media profile, and Megan Harris, who practices artistry. So she writes codes to produce illustrations. And Alison Horst, she makes beautiful illustrations of making very hard, complex ideas to be represented as small things, very funny way. And what you see down is Minnie Rundle, from whom I have adopted some of the slides. And you can go type for her recent talk, wherein she has an extensive talk on best practices for reproducibility, wherein she has elaborated, I believe, eight best practices, 8 to 10. So I came to R for the data visualization. I was very attracted to the data visualization and the power of reproducibility, and I stayed for the push buttons. So now we recently pushed a button, and this is a preprint. What you see is published from a push button. So we are working on the reproducibility aspect. That is, it is currently reproducible by myself in different environments, both in my Mac as well as Windows. Whereas I'm trying out reproducibility, testing the reproducibility of this paper with other scientists, so that we achieve the next step, that is, it is reproducible by others. It is the whole paper which I mentioned. So for you to ponder, I leave these questions for you to ponder. So where are you in the reproducibility spectrum? Think for yourself. And for you to move ahead, which practices, whichever you heard today, what you would want to adopt, and will you? That's the main question. So I was in an ordinary world, I would say. Now I have moved to a world of push buttons aiming to automate and reproduce. And I would want you to think that world exists. And uh, I want to close the loop here, that I started with empowering research, because how reproducibility empowers researchers. Now I ensure all my results can be independently verified and validated by other researchers. I'm working towards these things. So this definitely enhances reliability and trust in the findings. And it also promotes openness and collaboration, which I believe on the larger front accelerates scientific progress. The most important takeaway from this lecture should be practicing reproducibility benefits yourself. The principal beneficiary is the author themselves. And I would want to end it here. And this is an illustration which was made by Alison Horst on reproducibility. Nothing further. Thank you.